Hello, everyone. Um, Coming back after the break. So we're gonna continue conditional processing. So now we learned the basic idea behind the conditional processing, which is the way the compare instruction and affect the E flag, and then the way the J instruction is going to make the decision. And we learn multiple type of J instruction, and hopefully that's going to be clear in your mind right now. Okay, so now we're going to jump into the conditional structures, and we're going to look into the if statement. Okay, so if statement is something you guys have already learned in your introduction to programming, either Java, C, or Python. So we know that in the if statement, there is something very subtle right here. So if you understand that, as I explained in the class last time for one of the sections, that in the high-level language, the logic is a little bit different. So if we say if a is greater than 10, then we're going to have a statement controlled by, we call the then statement, right? Otherwise, we're going to go to the second statement. So now we understand from the conditional processing that first we need instruction that's going to evaluate the situation right here and instruction that's going to make the decision, right? So if this condition is true, that's the way you think about it in the high-level language, then you're going to do the statement and you're going to do the other statement. So in other words, you did not jump over the statement. So in a high-level language, if both of these happen to be a true, then we're going to enter the then, and then we're going to go to the next. Okay? And if this condition happens to be false, okay, let's say we have 20 right here, 20 is not greater than 10, then we are not going to execute this statement, correct? You with me, guys? Then we're going to jump over it. This is very important to understand. So the whole idea right here, we want to know the jump. So the jump is going to be based on the condition is false. If it's false, then we're going to jump. Okay? That is very important. All right? And then the rest just is going to be mechanics. And we're going to see, is this the case when we deal with the assembly language? Or is this the way? Because languages, they're just going to show you views. So this is how you view it in Java. But when you go to a low level, you have different lenses. So we want to know the view at that level. All right, just to remind you with the if statement, and that's what I talked about right now. It's the false and the true. So this is like self-explainable. Just look at the slides. Hopefully you're gonna capture that. And if you haven't already been introduced to this, right? So the whole idea right here, when the condition is true, execute the body. And that's what I talked about here. That is this part right here. Okay? So if that is the case. If that is not, then we need to jump. All right? That is, just thinking about it is helpful. Maybe you know it, but you're not aware of it. So I just need your awareness, because at the assembly level, we want to do more details things. So we want to look at things from a different perspective. So this is a basic if statement. So that is your condition right here. If it's true, then go to the condition code. If it is false, then just move on to the next statement. Okay, so this is nothing new. That is the if then statement. Correct, guys? And you are aware of that. And then we have if then else. So this is if this is false, we are not going to go to the next. We have an else statement, and the situation can be very complex if we use if else, right? Else if, I'm sorry. But I'm just going to focus on the simple one. Else, maybe do two statements and then move to the next. So if now is complex statement. It has true part here and false part here, because if it's true, we're going to go here, and again, this is very important, we're going to jump over this, because we cannot do if and else. If this is true, we do this and we jump over the else. You see it? If the condition here is false, we jump over the then and we go to the else, and then we will continue to the next. You see what I'm talking about? So the flow is like, it mainly depends on whether the condition is true or false. So we have two jumps. The first jump, the condition is true, We are not jumping over the if then, but we are jumping over the else. If this is false, then we are not going to do the then statement. We're going to do the else. So we're going to jump to the else. All right. So we're going to capture that in more details just in a minute. All right. So this is what the condition is. So of course, if you see an if statement, always use a compare statement right away. We're just going to use a compare. All right. So we're going to replace if with compare. And we're going to replace this condition with assembly parameters. All right, and then we're going to use the right condition jumps. That's exactly what we want to do. All right, one key points right here. Key point right here is if you are comparing memory to memory, we know compare is a subtraction, so we cannot subtract memory from memory. So that's what you see right here. So in this condition right here, we said if one of those two operands are memory, move one of them to a register. So that way you're going to compare memory to register. And we understand that, right? x86 is a register memory architecture. But of course, if you have memory with an immediate, that's fine, okay? So that is the whole idea. I'm trying to explain what I was talking about right here. So when a condition is true, execute the body. When condition is false, do not execute the body. Jump over it. Do you see it here? Jump over it. So now we want to see, is this the case in assembly? All right. So the jump when the condition is false, keep that in mind. If let's say, if right here you have A, let me see. Okay, this is hard. If we have A as 20, that's false, right? So A is not greater than 10. That is the compare is going to figure that one out. Then the J instruction is going to figure out based on the condition that this is false. If it's false, that means it's going to jump over, right? It's going to go to the else. This is how it works. Right, guys? Okay. So if that's the case, then the key idea right here, x86 to jump when the condition is true. You see what I'm talking about? So if I can translate this simple statement, let's just start with the if statement, the one that we have right here. Okay. If A has a 20, in this case is true. I was wrong when I say it's not false. So just imagine it was 2. All right. So then we have a statement right here. If we want to translate this, we're just going to say compare. And just imagine A is a register AL. So we're just going to say compare AL to 10. That's how we're going to do it. Okay. And then we're going to say jump based on how we want the jump. I mean, the J instruction. Are we going to do it above, below, greater, less than? That's going to be based on sign or unsigned. And that's what I prefer to use. You could use the 0 or whatever. That's fine. Okay. So in this case, I would say a jump when it's above. And just keep in mind that this is 2. Let me assume that this is 2. Okay. We're going to say jump when it's above, because we're translating greater than into above. A jump when into above, when, let's keep it 20, I'm sorry. A jump when it's above, so this is above, right? So here when jump, because it's true, right? We're gonna jump to the then, but usually in the high level language, if it's true, we just go right away. I'm not sure if that's clear, okay? But in assembly, if we keep this one, if we keep this operator the same, jump when it's above, to then, or we call it the body, you can call it that part, okay? To then we're making things a little bit complicated. Let's look at it. We're gonna go to the then label, and let's say in this statement we have b equal to 5. So we're gonna go to the then, and we're gonna say move to BL5. And then we're going to go to the next. So here, this is true. So we jumped when it's true. In fact, here we don't jump when it's true. We go to the next. So when we translate it directly using assembly, that's what happened. It's not wrong. It just makes efficiency or readability hard. That's all. But it's not wrong. It's going to make reading the code harder. Okay, we'll figure out a way in how to solve this problem. All right. So if you look at it right here now, so what if it's false? If it's false, then we're just going to go maybe to the next statement, right? So maybe it's going to be, if it's false, then we should go to the next statement, right? So just imagine that we have a next statement right here, and C is equal to 9, right? So what we're gonna do here, if it's false, then we need to jump, right? Don't you agree? Don't you agree? If it's false, then it's jump, right? Okay. So if that is the case, then we're gonna do one thing, right? So we're gonna say move to CL9, right? And then we're just gonna say what? We're just gonna say jump next. Very complex. So here we're gonna have what? Next. Whatever you have next. So just imagine this is the translation for this one statement. And here we say jump when it's above, but in fact, this is true. 20 is greater. We should not jump, but we just did the direct translation. So we did it. It captures this case. Let's just imagine if we have 20 in AL, is 20 above 10? Yes. Then we're going to go to the then and next. So in the next, we should have what? C equal to 9. It's not here. Should we bring this C equal to 9 right here? Do you see what I'm talking about? Because we want to go there anyway. So that is kind of, we're going to go back and we're going to move to CL9. But we know when this is true, we are jumping above to the then, and then we're moving to the next. What if this is false? Okay, so if it's true, then it's 20. 20 is above, right? Then we're going to go to the then, and automatically we're going to go to the next, right? So what if this happens to be 2? If this happens to be 2, then is 2 above 10? No. Then the CPU is going to go to the next statement. So in the next statement, we are moving this. We should not, right? Because it's false. We should jump over it. Okay? So it's going to require us rewrite the whole thing. All right? So this is just, I know if you are confused, that's okay. But I'm just going to show you that this is a little bit complex. We're going to follow an easy way to do that. Okay? So that is what you see right here. So you need to reverse in order to make writing the statement easier. You need to, but you don't have to, okay? If you want to make things better. If you feel like if you have a way to make it work and you verify that it works when it's true or it's false and you like it, that's fine. But remember, when we write a code, we don't write it for ourselves. You're going to be maybe working on this particular organization for some time, and maybe you're going to move somewhere else. Someone else is going to come and read your code. So they don't really know the way you think, or they don't even have an idea. So at least if you want to force your way of, or your thought process, provide comments, please. So that way they will understand what you mean in your code. Because in an if statement, that's how it works. True, do then, and go next. False, go next. That's how the if works. You should capture that at the assembly code. So the question right here, as you can see, how to reverse a condition. Okay? Because why we need to reverse? Because in assembly code, we jump when it's true. In the Java level, we jump when it's false. So if we want the assembly code to capture the Java or the C level, then we have to reverse. We have to reverse. Instead of jumping where greater than, we need to jump when less than or equal. Okay, I'll try to explain that by examples. So if you remember, we have the De Morgan law, and that is used for condition negation, or conditions, or Boolean operations negations. All right. So if you see greater than, it's going to be less than or equal. Greater than or equal is going to be less than, and so on and so forth. So you need to remember this table. You need to keep it in mind. Okay. And I assume that you already been introduced to this in the introduction to computing. I'm just reminding you of the fact right here. So let's see how can we, let me see if I can move my video a little bit here so you can see the side. So that is the if statement. Do you see the red box in the right corner? I hope you do. So first we need to translate if. So we need compare and we need a conditional jump. We know that, right? And we want to make sure that the operands we have, they are not both memory. If they are, then we have to move one of them to a register. Fortunately, right here, we are dealing with the unsigned, and both are registers. We just need to compare them. So if EBX is less than ECX, then we need to move 5 and 6. Right, guys? Is that clear? So let's do that in the board. Okay. So I changed the corner a little bit of the board because in the video when I was previewing it, I thought that it was a little bit far or a little bit behind. It doesn't look the way, at least I see it in my from my view right here. All right. So F means what? Compare. We are comparing what? EBX with what? With ECX. Correct, guys? Okay. So once we compare these two, we want to make a decision, right? So the condition here says less than or equal. We know if you want to do it that way, it's fine. Please try it at home. But I want to reverse it because I said reverse the condition. So we're just going to say jump. And remember, you see it in red right here? It's unsigned. So jump when it's unsigned. Then we are using A or B, above or below. That means something, by the way. It's very important. Okay, so we're just going to say jump when it is what? Less than or equal. That means what? Above. Okay, so we're going to jump where? Where are we going to jump? When we say jump, if it's above. So if it's above, we're going to do what? That's false, right? And that's exactly what we do. When it's false, we should jump, right? And now it's false because we reverse it. So we're going to say go to the next, right? Okay? If it's not false, then we're just going to execute the then. So we're just going to say move to EAX 5 and move to ECX or EDX, I'm sorry, 6. Okay, and here I will have next, whatever that next is. Maybe you're going to have a statement or two in there. So if you see it right here, if you have 10 right there, just look at this 10 and 5. Okay, and this condition, just look at it in the board right here, in the slides right here, guys. I'm sorry. So is 10 less than or equal to ECX? It's not, right? So what's we going to do? What are we going to do? So if it's not, then we're going to jump over and we go next. We are not going to execute the body of the F statement, correct? So that's exactly what it is. So is 10 above? Yes. So we're going to go to the next. We're not going to execute the body. Do you see it? Okay, so it makes things easier. All right, what if this is 50? We're comparing 10 to a 50. It's teeny tiny right here, but I mean 50, okay? I know, I can see it, but maybe you can't. It's 50, and this one is 10. So here, is 10 above 50? No. So we are not jumping. We're going to move 5 to EAX. We're going to move 6 to EDX. That's interesting. Let's look at it here. Is 10 less than or equal to ECX? Yes. Then we are not jumping. We are moving. Do you see the reverse here? Okay. So we should do this without reverse if you would like to. Do it without reverse and you will see what happens. Okay. So this is exactly what the case is right here. We jump to the next. Otherwise, we're just going to move the both. Okay. We're going to move both. I mean, we're going to move 5 and 6 to EAX and EDX registers. All right. So this is another example. But right here, we have what? We have if else. And that's very interesting. We want to reverse again. But remember, we have operand 1 equal to operand 2, right? If operand 1 here equal to operand 2, that means I'm comparing two memory. So I have to move one of them into a register. And then I'm going to compare with the others, okay? Which is the operation, the operand number 2. And it's simple. If you see this in the quiz or in the test or in the assignment, if you see an F statement right away, you're going to say compare. But now I know I have two memories. So before I do that, I have to move, let's say if I'm assuming 8-bit register or 32-bit register, that's up to you. Or that's not up to you, that's based on the problem. So you're just gonna say, for my case right here, I say move to AL operand 1, that's a memory. And then now I can use compare AL with operand 2. So that's the register memory comparison. And then the rest now, I wanna do the condition right here. So if I want to reverse, so here is equality, right? And if this is equality, let me see if I can move this one a little bit here now, since that's clear. If this is equality right here, then we're going to reverse equality. So equality means what? Not equality, right? If we want to reverse it using the Morgan law, right? De Morgan law. So in the De Morgan law, it's going to be what? It's going to be not equal, right? Okay, so we're just going to say not equal. Jump if it's not equal. To where? We are not going to go to next. We have else here. Okay, so you need to go to else if it's not equal. If it's false, go to else. If it's true, then just move to x1. But by the way, here we're going to have else, right? And inside else label, we're just going to say move to x what? 2. But right here, if you see something missing, right? If we do this, jump when it's not above. Just assume that you have 5 and you have 4. 5 not above. Is that true? Yeah, it's not above, right? So we're going to go to what? It's not equal, that means. Sorry. So we're going to go to where? We're going to go to the else. That's not an issue. Okay? The issue of this is 5 and this is 5. Okay? So if AL5 and operand 1 is 5. Okay? So if this is 5 and this is 5, then not equal? No, we are not going to jump because they are equal. So we're going to move 1 to x and we're going to move 2 to x. This should not happen. So when we move 1 to x, we should what? We should have unconditional jump to the next. So that way we end up not executing if and else. Okay? Just doing one of them. I mean, executing one of them. So here I'm going to have next, and whatever I have in next here, it's going to go right there. Okay? So this is what you're going to see right here. Okay, so this is exactly what it is. Please try it at home and make sure that you have a piece of paper, some values, and try to trace it. And then try to write your code without reverse. See what happened. Okay, guys, this is do not reverse. This is in this case. You can see it in here what happened. I mean, what's going to happen if you don't reverse. So if you look at it right here, you compare and you jump when it's less than or equal. Do you see it? So this is less than or equal. You're going to go to L1. So that way you are jumping where you shouldn't, but you did it, who cares? And you move 10 to var 3. And then you move next right away. Okay? So right here, if it's not less than, based on the value, we're just going to go to the else. So reading it, it's just, I'm reading first else and then. So I call it drunk if, upside down if. Okay? It's a drunk if, but there is nothing wrong with that. There are multiple ways to write this code. Just as I said, keep in mind efficiency, and readability. So you need to have proficiency when you write the code. And that is to say, I'm not just solving the problem. I'm solving the problem, and I might move somewhere else, and someone else might need to come and update my code. Okay. So this is like a simple if statement and FL statement. And if the whole idea is, I just want you to think more about the main component, how F works. I know how you guys know how to use it, but I'm not very sure that you know how it works. So hopefully this is going to push you a little bit more. So we're going to look at like different type of Fs, because Fs sometimes have compound statement, right? It's a compound expression. You have this and this or this, right? So you're just going to look at that. That should be straightforward if you already got the idea of F statement. Compare and jump, reverse if needed, okay? So right here, we are comparing AL with BL and BL with CL. So there is something very critical right here, okay? And we call it short circuit evaluation. What short circuit evaluation means. So let's just look at this expression, guys. It's an AND operator, right? So if this is false, does it really matter whether true or false in there? It doesn't, right? So that is a short circuit. If this is false, get out. You don't need to bother and waste the time processing the second condition and figure out whether the second condition is true or false. You don't need to do that. What you need to do is just, you're going to look at the first one. If it's true, yes, move and process the next one. Okay, if it's not, then you have to get out, because this is true, but this is false. You have to get out. In an end compound statement, we have to have both of them. But this is something, sadly, we haven't been doing, or we did not do for quite some time, until recently, when we realized that we should go with the short circuit. So if you don't do the short circuit, that's what the short circuit is that the first expression is false, then the second expression is going to be skipped. Okay, so that's what it is. So if you don't reverse right here, what happened? You're just going to use the same jump when it's above to L1, right? And then jump when it's above to L1. You are actually comparing, even though this is false, okay? Because this is false. It was not above, right? Okay, if that is the case, then why you have to do it that way? All right, so you say jump when it is above. So this is above, that means true, right, guys? We're gonna go right here, and then we're gonna compare this. All right, so that's the first expression. Otherwise, if this is not above, we're gonna go where? We're gonna move to the next. All right, do you see the idea? Okay, so in this case, you did not reverse, okay? And let's look at the other part. And now we're gonna reverse what we did right now. And when we reverse it right here, do you see the amount of code that we reduced? Let's just show you here. This is what we did in the beginning. We compared without reversing, and here we compared without reversing, and here we compared with reversing. So do you see the amount of code that you have here and there? So there is a section in the book that talks about readability, and size of the code could be reduced if you reverse, but that's not always true. 60% of the time, 60 to 70% of the time. So if you see exceptions, that's okay. So we are not saying 100%, but this is a good practice. Just you make the decision based on the given problem and based on the given situation. But the whole idea here, to me, what I want you to focus on is the conditional processing idea. So this is how we handle the conditions. Compare, it's going to do the subtraction, affect the flags, jump, or the J instruction, it's going to jump when it's true. Otherwise, it's going to move the instruction pointer to the next instruction instead of jumping over the next instruction. Okay, so this is basically another example for an if statement. Can you give it a try without, and you reverse the if statement? So you have F and another F right here. So you need to think about it. So it's straightforward. We need to compare instruction, right, guys? So we need one compare right here for EBX, right? With what? With ECX. And we need another compare for ECX with EDX. And we need to have JJ, right? So the J right here, we said it's unsigned right here. So you need to use above or below. So here we said reverse. So it's less than. If we have less than that here, we say jump when it's what? Jump when it's what? Equal, right? Right, guys? Less than or equal is going to be what? Equal? It's not. What it is then? Less than or equal is going to be what? Greater than, right? So, but greater than, we're going to say it differently here because we are doing with the unsigned, we're going to say above. So if it's above, then you should do what? You should go to the next. Get out. Okay, we're going to go to the next. Okay, if it's not, then we have to go to the next statement and make sure whether that's true or not. So in the next statement, we already have the compare. So we're going to look at the condition right here, which is, if you can see it right here, it's greater. So this is going to be what? It's going to be less than, right? Or equal. So that's going to be what? Below or equal. So if it's below or equal, then go to the next. So we're going to go to the next. So let me see. I don't know if you guys can see it up to here, but I hope you can. No, you can't. So you're just going to go to the next here, right? Okay. So if that's the case, we're going to go to the next. Otherwise, we're just going to go to the next statement, right? So whatever the statement right here, which is moving 5, I'm moving 6 to the registers. Okay. So the solution, you have it right here. And this is exactly what the case is. Jump when it's above and jump when it's below or equal. All right, guys? And you can, of course, solve this problem in a multiple way. This is not like the only solution. And the same applies to the OR statement. Okay? So if you can look at the OR statement right here, it's similar. But the only thing here, when you do the OR, if the first one is true, we should go right away and execute, right? We only go and compare the second statement or the second expression if the first is false. Because in OR, if this is true, that's enough to go and execute the statement. If that is not true, then let's go to the second expression. And the second expression, if this is true, we're going to go to the statement. If neither is true, then that means it's false, then we have to jump over it. So we need one expression to be true. If that's the case, do not go and process this. Just go right away. Okay? So this is efficiency. Again, if you write a code in Java or C and you want to make it more efficient, just look at the assembly code. And then these are the things that you can tweak. That's what they do in the performance computing community. Okay, so this is reverse the second condition, not the first. Because if the first true, just go and execute. You don't need to reverse here. So reversing the first condition is not advisable, but please try it out. You might feel it suits the way you think. But again, it's not about you. It's you want to write something that's going to be understood by others. Okay, so here, if you look at it, we just say jump if it's above to L1, and we move to L1, we move 1 to X, and we end it right there. That's it. This is true. Move 1 to X. End of the story. Okay, but if this is false, we have to verify that this is not false. If this is also false, then we have to get out. We are not moving 1. So that's when we compare the second statement. We say compare BL to CL. The jump, when it's below or equal to the next, that's when we reverse. You might wonder why. Just as I said, again, multiple ways to solve the problem. Just look at this, try this when you don't, and see if you see any difference. At least for this particular example, you might not see it very clearly, but in general, this should be the case. Okay? So that's exactly what the F statement is. So we're going to just look at a couple of examples, and then if the time allows, we're going to do the while statement. If it's not, then we're going to take a break, and then we're going to continue on the while statement. And with that, we're going to be ready to move to week 10, okay? So as I promised you, I will go over the missed lectures and week 9 lectures, and hopefully those videos are going to help. I know it's better to be in touch or in the way we do in the on-class lecturing. But of course, as I said, I will have office hours, online office hours. So that way you can talk to me if you have any concerns or you have any questions. We're going to use the WebEx or the Zoom, whichever is going to help me provide the service to you guys. All right. So now let's look at this example. It's a little bit complex if you look at it, but it's straightforward in terms of translation. So the whole idea of this example right here, guys, is we are searching for an element inside an array. So just look at this array, the one at the top right here. So we are searching for a values in this array. And this values has to meet some criteria. Okay, so the simple criteria is going to be this. The first non-zero value. Is this a non-zero value? It's 0. So we keep searching until we get 1. Once we get 1, we're going to get out. Here in the second example, you get non-zero right away. Here, no non-zero at all. Here, you have 1. So please try all of them out. I'm just going to focus on the first example. So this is a perfect example for using loop and F. You want to read the list, and then you're going to check. So that's when we're going to need the F statement. Okay, so let me see now. Let's look at this example very closely. So first, we declare the array, as you can see it in the top right here. Okay, so this is our array, and it has the values. It's a signed word. It's a signed integer. Okay, so it's an array of 2 bytes, right? And then we're just going to look at the code right here. So we just have, this is a memory access mode that we learned in the class. So this is indirect, right? So we're taking the address of the integer array, the variable name, and we assign it to EPX. You might wonder, y to ebx. You can just, I'm trying to show you that you can assign it to anything you want. Okay. And then now you want to know the length because you want to use the loop instruction, right? So you want to know what is the length of this array, how many elements we have in there. So we don't need to count them. We're just going to say the length of the array, and then we're going to assign it to what? We're going to assign it to ECX, right? So once we do this, we assign it to ECX. Then now we know the loop instruction, the one that we already covered in chapter 4, is going to go and subtract 1 each time from ECX until we exhaust the entire array. All right. So if that's the case, first we want to compare the first element, which is it's similar to ESI right here. We're just going to say the first element, which is this 0 right here. Okay, do you see it? It's right here. And then we compare that with 0. So the way we access is the PTR. We say word, but accessing a word, though this is an S word. Okay, so it's the same. If you want to make it S word, that's up to you. And then we say jump, not 0. So go to the found if it's not 0. But in this case, the first element is 0. We compared it with 0. So subtract 0 from 0, right? That's how the compare works. And then the Z flag is going to be what? It's going to be 0. So that is not true. So the Z flag is set. And here say jump when the Z flag is clear, but it's set. So we have to go to the next instruction. So we're going to add to EBX2. Why? Because we want to go to the next element, and so word array. So we're going to offset by 2. Okay, and then we're going to loop back to L1, and we know how the loop works, right? So the loop is going to subtract 1 from ECX, right, guys? So it's going to go to ECX. Just assume that this ECX has a 10 elements, so the loop is going to first subtract 1 from ECX, is going to be 9, and then it's going to compare this into if it's not equal to 0. So this is not equal to 0, then it's going to jump back. The next time it's going to make this one 8, and then it's going to go until it gets it to the 0. We already covered that when we learned the loop instruction, right? So that's coming back to the loop right here. Then now we're going to, that's not true. So we're going to jump back. We're going to compare the second 0, right, with the 0. So again, the Z flag is still clear, okay? Sorry, still set. And we want to jump when it's clear. So we're going to add, we're going to go to the next 0. And we're going to subtract 1. And we're going to do this until we get to the 1. So imagine, right, when we go back here, we have a 1. So EBX as a pointer points at a 1. So we're comparing 1 with a 0. When we subtract that, so the 0 flag now, it's not set because the result is going to be something else, right? So that's when we're going to say jump to the found. Okay, so in the found right here, we want to move the value where? To EAX. Since this is a 2 bytes array, then we want to move it using the move SX because it's going to extend the value, right? Otherwise, we're going to have mismatching. Right? Remember when we learned move SX and move ZX? So that's the whole idea right here. So we said move this value to EAX and extended it based on the sign. If it's negative, make the extension with negative. If it's positive, make the extension with positive. Okay, guys. And then we're gonna say this is a new function. We're gonna learn those in more details in chapter 8. But this is like in Java, right, Lynn, or in C, like printf, or so you're just going to call this external library, right, Len? And it's automatically going to go to EAX. So if you can read about it, it's in the bottom right here, right, Len? Write string and clear the screen and get the prompt into the top, the top leftmost, okay? So if that is the case, then this is what we're going to do right here. We're going to write the value and we're going to jump to what? Quit. Why? Because if we don't this, we're going to do both F and else. Okay, or means we're going to do found and not found. So we're just going to go here, clear the screen, and exit. Okay, if you apply this program to the array that has only 4 zeros, okay, so you're going to exhaust the whole array. You're going to go here, 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 because these are all zeros. And then you're going to jump at the end. When you're going to get out of the loop, you're going to go where? Not found. So you're going to jump here and you're going to write a message. If you want to write a message, you're just going to take this message. So this is a variable that has the message. If you go back to the slides here, you see it right here. This is the message that we have. You see it, byte, it's equal non-zero value was not found. So this is a byte variable that we declared right here. Okay, so you can consider that as part of the program. All right, so we're just going to take the address of the first byte in the memory of that string, of that thing that we need to print out, and we assign it to EDX. All right, and then we're going to call write string. So write len, consider the value to be assigned to EAX. If you don't, it's just going to go with the default. And write string is going to consider the value to be EDX. So that's why we assign it to EDX. So it must be EDX. It must be EAX right here. We're going to talk about this in chapter 8, but these are like external libraries. Okay, they are high-level things. I'm not very much interested on learning them for now. Okay, guys. Is that kind of clear? So this is mainly the F statement. So we started from conditional processing, what's test and what is compare, what is J instructions, and we put them together and we use them to translate an F statement. And we learn the De Morgan law, and in the De Morgan law we learn about how these components put together to write an F statement, okay? So the upcoming slides are gonna be mainly about the while loop. So while loop, to me, again, it's an F statement, okay? So basically it's an F statement. So if you wanna look at it, that's what it is. The only difference that you need to keep in mind, because if we say while, we have a condition here, a less than 5. So if this one, that's the body of the while loop, right, guys? If this is false, we're gonna jump. We are not gonna execute the body of this statement, right? But if it's true, we're gonna do the body. And the difference with, in comparison to F, you're gonna do the same F, but here you have to jump back if the condition is still true. But in F statement, we only do things one time and then we move on. Do you see what I'm talking about? So it's gonna be identical. Let's look at it. So that's a while statement. We have two values, value 1 and value 2. So we cannot compare two values, right? One of them has to be a register. And then we're just gonna either, if it's true, we go to the body. If it's false, we're gonna go out. So again, we need to reverse. It's better to make readability easier, but you need just to try it out first. So this is what I talked about right here on the board. You have the details in there in case if you want to look at them. Okay, so if we want to do this one with the reverse, this is straightforward, guys. First, we have to move val1 to EAX because we cannot compare memory to memory. And then straightforward, why we need this? That is the loop name. So you can give your name right here. It doesn't matter. So you will see why this is important. So first, you need a label, and then you're going to compare. This is always true. That's going to be always the case. So we're going to compare EAX, which is val1, with val2, and we need to reverse. So reversing less than, it's going to be greater than or equal. So when I say greater than or equal, am I considering signed or unsigned numbers? I know you're guessing right now. It is a sign because it's greater or less than, right? So these are the things that the CPU will use to decide whether the human or the programmer programmers mean that this is something signed or unsigned. So we know it's a signed value, okay? And then if it's greater than, go to the end of while. That means this is false, get out. So we say end of while, we just, in the end of while, we're gonna do whatever. Move the updated value in EAX to val1 because we don't wanna change the value of val1, okay? If you wanna leave that one out, it's okay. Save the new value to the val1 because you didn't do anything, okay? But if this is jump when it's greater than, in this example, okay? So we say less than. So if we say 10, then this is, we're comparing 10 with 5. 10 is not less than 5, then we're gonna go out, end of the while, and we're gonna move whatever the value in EAX, which is exactly the val1, we did not change it. But just imagine, so now A is not a 10, A, just imagine it's 2. Is 2 less than 5? So is 2 greater than or equal to 5? No, we are not jumping. Then we're gonna get into the body. Inside the body, we're gonna increment EAX, decrement EAX, and then we're gonna say what? Jump back, where? To the beginning of the while. That's why you need that label, okay? So it's always, this is the way you translate while loop. You need a label, call it L1, okay? And it must have the colon, and you need the compare and the jump statement. And you need unconditional jump right here, always. This is exactly what the format is. You need to keep this in mind. And the rest here is the details. These are the details. These are the things that you have given by the problem. But this is things that label, just call it W1. That gives you the meaning, gives you the sense that it's a while loop. And then compare, jump based on the problem. And you need to jump back to L1 always to the label. And then compare again. Are you still true? Yes, then continue. Are you false now? Yeah, get out. Okay, so this is exactly what this statement is. So we're just gonna increment, decrement, and then we're gonna jump back and compare. So when we reach the point when val1 is no longer less than, that is when we're gonna jump out. And then we're gonna assign the value of EAX back to the val1 because we keep incrementing EAX, by the way, not the val1. So at the end, we need to update the memory with the whatever the effect that we have in the val1. Okay, guys? This is another example, straightforward. Just look at it. These are multiple examples, but the idea remains the same. Okay, so this is the example that I would conclude the class with, which is mainly the searching an element in an array. All right, so we search an element in an array, okay, and if it's greater than the value in the sample, which is 50, then we need to sum it up. Okay, so this is the sample, which is 50. If this value is going to be greater than 50, we will sum it up. If it's not, then we're going to go to the next. So this is not, 10 is not, 20 is not, 33 is not, 45 is not, 18 is not, but the rest are. So we need an if statement and we need a loop. So right here, we are not going to use the loop instruction. We have our way to write our own loop. So we need no longer to rely on the loop instruction. Do you see what I'm talking about, guys? We are not going to use loop. All right, because we can write our own loop, because that's what the loop does. It compares, it jump, if the condition is true, it get out. If it's not, then jump back and so on. That's what this actually does. So now we're going to write it, write the while loop or write the loop instructions using our own code. So this is exactly what the array is. Just look at the structure in case if you have weaknesses in terms of how the loop works. And if I were you, I will give like a simple example, the one that we given before, and try to play with it. Okay, so this is the if statement nested inside the loop. All right, so we have this loop right here, the while. It's going to search for the array, and every time the array element, number 1 or number 2 or 3 is greater than the sample, we're just going to sum it up. If it's not, then we're going to go to the next element. You see what I'm talking about? So this is what the code is in C language. And we want to translate that into an assembly code. Okay, let me get the video a little bit to the side on the window. So that way we're going to focus. All right, so this is my array right here. So no brainer. We're just going to have this array word, and these are the elements. And then we have the sample right here. It's an integer. We're just going to have the D word. You might notice that integer is assigned. We should have S word. You can do that. If you assign a negative value at the runtime, we know that's going to be taken care of, right? So just keep that in mind. Okay, guys? So the sum right here, this is our sum that we have. This is the array size. That's the sum integer. Do you see it? So this sum is being captured right here. All right. And this is the index that we have, right? So the index right there, it's going to be a 0, right? So right here, we have the array size. This is something a little bit interesting right here. You see the array size? So the size of the array divided by the size of the sample. All right, so the size of the array divided by the size of the sample. Remember the $, the one that we learned in chapter 3 or chapter 4? Remember that? So that's going to give you the end of the array. So if you have an array, a list, a memory, we understand this is A equal to 5, 6, 7, 8, 9. The $sign always point at what? The last element, right? So that's what the $sign is for. So if you subtract this from this, it's going to tell you the number of elements right there. So that's exactly what we did right here. We want to know the array size. You might say, why didn't I use length of or size of? That's up to you. So we use this $sign and we divide it by what? The type of array. Why? Because we know the $sign is always calculate things in terms of byte, right? So we say the type of the array. So whatever the element is, if you have like 8 elements, that means that if you have 8 bytes, you have 2 elements because you're going to divide 8 by 4, right? So you're going to have 2 elements because $sign is going to tell you how many bytes and a memory of size 4. But we don't need the number of bytes. In fact, we need the number of what? We need the number of elements. So the block, when it's an integer, is of a size 4, right? So we're going to divide it by a 4. That's why if you have 40, the number of bytes, and you divide them by 4, then it's 10. And that makes sense because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 multiplied by what? 10 elements by 4, because it's a memory of size 4, right? That's what it is. If it's a D word, remember that? It's a D word, 1, 2, 3, 4, that's one memory. And then 1, 2, 3, 4 is going to be another memory, right? So here in terms of bytes, it's going to say 1, 2, 3, 4, 5, 6, 7, 8. But in fact, we have only 2 elements, not 8 elements. But the $sign, the way the $sign works, is going to return the number of bytes. All right, guys. So if that's the case, the rest here is going to be just this is we moving 0 to EX. That's when we need to sum the values. And then that is the sample, the EDX. So EDX has the sample, which is 50 in this case. And then we're moving 0, so we're using the index. This is the memory access mode. And then we're moving the array size to ECX. Okay? So if we do this one right here, then we're just going to do what? We're just going to compare ESI with ECX. So ESI has what? A 0. ECX has what? Has the array size, right? In this case, the array size is what? 10. Okay? So jump when it's less than. Is 0 less than 10? Yeah. Right? So we're just going to go to L2. So in the L2, we're going to look at the elements, which is ESI multiplied by 4. So what's in ESI? It's 0. Multiplied by 4 is going to be 0. So I'm looking at the element 10, which is element number 0. So I'm comparing this with EDX, and EDX is 50. Okay? So the element here is 10. Is 10 greater than 50? No. Then we're just going to go to the next statement. We are not going to go and jump. So the next statement happens to be jump to where? L4. So in L4, we're going to increment ESI. So when we increment ESI, ESI is going to be what? 1, because it was 0. And we're going to jump back to where? To L1. So this is now, it's a 1, and ECX is a 10, right? Is this less than? 1 less than? Yes. So we're going to go to L2. And then now we're multiplying 1 by 4. That means the element number 4, which is 0, 4, 8, 12, and so on, right? So now we are moving to 60. So if that is the case, we're comparing 60 with 50. Is 60 greater than? Yes. So move to L3. So that way we are summing up. We're taking the value, which is 60. We're adding it to the 0. That's the first value. We increment ESI. We go back to L1. So ESI now is a 2. 2 less than a 10. So that's less than. We're going to go here. So 2 by 4, we're going to be 8. So this is 0, 4, 8. We're going to go to the 20. And that's not greater than, and we're going to repeat the process again and again. You got it? So this is an application of both while and if statement. You see it? So if you can see it right here, this is the loop, the while loop, and this is the if statement, the nested loop. I mean, the nested if statement. Kind of clear? Just play with it. Okay, that's the if statement. All right, guys. So with that, we actually finished chapter number 6. So we're going to move to chapter number 7, where we're going to look into arithmetic, integer arithmetics. And we're going to see what happens next week. So the next week, you will see the update this week about what is the plan, what is the online plan for the rest of the semester. So we're going to have an updated syllabus in terms of tests, quizzes, and office hours and lectures, and everything has to be adapted to the online system. And this is something I haven't done before, but I believe I can do it. The only thing I'm missing, to be honest, is your questions, is your energy, is you making me move around. And sometimes your questions are making me mad, and sometimes they're making me happy. And that is that's the reason why I love to teach, you know, it's the interaction. I'm missing it, but hopefully we're going to get used to it for a while, and hopefully the coronavirus is going to leave us alone. So in conclusion, this is the bitwise instruction. We looked at them. This is the compare. This is the conditional jumps loops. These are what we covered right now. And this is the conditional structures, which is the if statement and the loop. And that's exactly the application of everything we covered in point 1, 2, and 3. Hopefully you guys enjoyed it. I know it's not my my best to present or to lecture the way I want, but this is the best we can do. We are trying to just get ourselves on track and try not to be affected by the coronavirus. Just live your life normally, stay home, stay safe, and hopefully many people around the world are trying to get rid out of this virus as soon as possible. So just let's pray for them to get it done so we're gonna go back to our normal life. Okay, guys, thank you, and talk to you very soon. Bye for now.